changes or you're confused about something, and then just please come to office hours, and that'll be the right place where we can talk to you about it. The other thing is just remember that you do need a passing average on projects 1 and projects 2 overall in order to move on to the group projects. So this is just ensuring that every student can fairly contribute to their group, because project 3 is such a big project. If you feel worried about this at all, then just come talk to me and we can figure things out. And then milestone 1 was due. I think the 4 late days kind of ended last night. If you are still stuck and haven't like fully submitted, then again, talk to me, reach out to me so we can make sure that we catch you up. It's not over, so don't just give up yet, but just reach out. And then milestone 2, hopefully most of you have started looking at it. And if not, then hopefully you try that out today. It is a lot shorter and building up on a lot of the same things that you've already done, just using databases as well. And then project 2 interviews have started. So I think today's the first day. If you were chosen for milestone 1, then you should have gotten an email for that. Milestone 2 interviews are going to be like the second half of next week. And then milestone 3 interviews are going to be after spring break. So just watch out if you are that third of the class that is chosen for whichever one, then check your email and we'll announce when we send milestone 2 interviews out. The people who don't make the passing average, Mike, they actually just, they will fail the class. So this is something that I've written in the syllabus from the start. You do need to pass both projects individually in order to even take part in the final project. And yeah, if you want to set up an appointment, Ronak, just message me. We can find a time to talk one-on-one. And if you do feel like you're getting behind, that is okay. You are not the only one in that boat. So remember, there's other students like that, but this is probably the toughest part of the semester. And you're now going to have to do some work to make sure that you can keep up and catch up. So if you feel like you're behind, either message me or your TAs about what's going on. Come to office hours. If office hours are getting too crowded for you, then just message and be like, can we set up some time outside of office hours? And I'll do my best to do that. The other thing, if you feel like you were too behind on milestone 1, maybe you only got to finish up like half of it and then you submitted or something like that, then we have this cheat sheet now where you can kind of go through and we say step by step what sort of things we need to do in order to have the board working properly, the restart button, as well as adding new users and kind of controlling what users can do. So hopefully this will be helpful. Even if you finished everything, then it's still something good to look through and be like, oh, was I doing it in the same way? Could I improve my approach? Something like that. And for those who haven't gotten to do it at all, then you can hopefully just follow this and catch up fast. Because for milestone 2, you are going to need a lot of this basic functionality in order to build on it and have the leaderboard side of things working. You can't really do a leaderboard if nobody can win the game. So yeah, I'll post a link for this on Slack as well, but it's here. And I can just post it in the chat too. Okay. Any questions with that? And you can ask them as I'm talking, but another thing I wanted to mention is if you're noticing that your Heroku is responding really slowly, there's 2 things you can try. One is that you can basically try to test your thing on 2 different browsers, and that could show that things end up faster. The other thing is make sure that you don't initialize your socket within the scope of your function component. If you do that, then you're basically creating a socket connection every time that your component re-renders, and that's going to be really inefficient and probably slowing things down. So that's why you should be putting this as a global variable at the top of your app.js file. and then passing this down into your other files to use. So you could either do that through props, or you could export it and then import it in other files. The main point is like you should only call this once at the top of your file. And then after that, you should just be referring to socket everywhere else in all of your React files. So try that if you're noticing the slowness. This should take care of it. Josie, if you are behind, you can still get a 70. So I haven't decided the exact rules, but the main goal is if you're behind, I just want to make sure that you finish everything. That's the goal, just like you have everything working. Deadlines we can kind of stretch around to a point. But that's only going to be if you reach out. Otherwise, there's no way I can really help you or know that there is anything to do. Is M1 more than half of project 2 percent-wise? So project 2 is 25% of your grade, project 1 was 10%. And then milestone 1 is worth like half of project 2. So milestone 1 is 50%, milestone 2 and 3 are both like, I don't know, 20, 25% and 25%, around there. Okay. And yeah, so for milestone 2, just some tips here. Same slide as what I put last time, but make sure you're reading the specs. You can go ahead and start by like creating your new branch. You can finish watching lecture 12 demo to see like how to work with databases in the right way. You should design your database schema. So remember that your database is not going to be the same as what I showed you in class. You're not going to use that same models.person. You have to make sure that you change it to fit exactly what you need. So add or remove columns depending on what you would need. And then you can follow the steps in the specs as well as here in the setup homeworks to actually set that up and use it. And I know some people were having circular import issues. A few students came up with good solutions. So check on Slack. I think AJ and Rainfist had some good solutions. So check there. I pinned those. Yeah, Mamoon. So you're going to have 3 Heroku apps by the end. This is mainly just because if we have one for each milestone, we can grade each milestone separately. And we're actually grading the functionality based on what happens on Heroku, not the code itself. Or like we are grading the code too, but that's a separate part of the rubric. That final app is going to be like the final app that you would want to put on your resume though, that type of thing. All right, any other questions before I keep moving with today's topics? Okay. All right, so let's talk more about code quality today. We started with unit testing last class, and there's some other aspects you're going to need to know about for milestone 3. Milestone 3 is really that week where you're going to clean up the code, improve the code and things like that. And the final thing that we haven't really talked about, which we will today, is linting. But before that, I'm actually going to get a little bit more into unit testing, actually. One thing I want to note is I know that the technologies we're learning may be, it may feel really fast, like we're learning a ton of stuff at this pace. Things are slowing down now. This is probably the last, well, this is the last kind of lecture you need for project 2. And this is one of the last actually like very technical lectures that we're going to be covering. The next few weeks are actually going to be more on the planning side of things and like workflow and things like that. So, you know, if you've come this far and you're kind of understanding these technologies, then you're really, we're pretty much at the end of the sort of technical scope. There is going to be more technical stuff, but that's like advanced topics that you guys choose. So it's not as high pressure. All right, so testing. I saw this in the last year's slides and I thought it was pretty funny, but here's a good example of like how you can test things wrong when you're thinking of like your test cases. So take a second and read that. It works on Tuesday, yeah. So the point here is like, if you got to make sure that you're doing the right test cases and like a broad enough set of test cases. So if you're only testing this function on Tuesday, then sure, it's going to work that one time and you can keep testing it on Tuesday and that's awesome. But if you're not worrying about other days of the week, then you are not testing this right and you're not figuring out that this function is actually useless and dumb. Every day is not Tuesday. All right. Oh yeah. Wait, hold on. Is there context to this that I don't know about? I just thought it was like witty. I feel like I'm missing something here. You guys can tell me in the chat, but I'm going to keep moving. So with testing here, we have only been talking about Python testing, which we did last class, and that was focusing on the server side. Most testing you're going to see is going to be server-side testing because the server is kind of the one that's handling a lot more complicated logic, more sensitive logic even. So maybe you're working with databases or passwords and things like that. So those are a little higher stakes. And that's why all the tests, like a lot of the testing you're going to see is going to happen there. But you can do testing on front end. And there are different ways of doing it. So there are unit tests, just like we did in Python. Maybe you have some complicated logic in JavaScript, or you want to see if your React component as a unit is doing the right things. You can write unit tests for that. There are visual regression tests, which is basically saying, I'm going to take a screenshot of the UI after I've changed some code. And I want to make sure that this looks the same as the previous screenshot before I made my changes. So maybe you're adding an if statement in your JavaScript code or something like that. I want to make sure that this doesn't just like break the UI entirely. And this is kind of a sanity check for that. There is also accessibility tests. So when we make an app, then we're serving different groups of users. And maybe you want to be able to serve users who have different disabilities. So hearing or visual, things like that. That's where accessibility testing can come in to make sure that we are testing the app out from those limitations. And this is something that we've done at Facebook too, in order to make it usable. Let's say if you are relying on dictation instead of being able to see the app, something like that. And then cross-browser testing. So this gives me a lot of PTSD actually, just because on my last team, we're a business product. So there's a lot of telecom companies that are using our product. They're a little bit older. They've set up their infrastructure in like the 50s, the 60s, and that kind of thing. So a lot of them are still using much more older tools when they access our product. That means they're using Internet Explorer instead of Edge or Chrome or Firefox. And Internet Explorer is super outdated. It barely keeps up with like the latest technologies in JavaScript and things like that. So, and also nobody has Internet Explorer. So it would be a pain to like create a virtual machine on Windows and then get that to work and things like that. So we did have like half of our users using our website from Internet Explorer. And as Facebook engineers, we were using like Chrome and later technology. So there was just that mismatch there. And that happens a lot. And you have to make sure that you take this into account. Because if you only look at Chrome, your users might not be Chrome. And Peter, yeah, this includes mobile too. So maybe you want to make sure that the site loads up nicely on a small device, different screen sizes, things like that. Okay, expose the fallacies of okay, Brian Kenting. I'm gonna have to look him up. Single div art. Yeah. It's true. Things do really get messed up like that. And I'm sure if you like try looking at your Heroku app from Project One on mobile, if you didn't take it into account, then you're going to see some weird dimensions and stuff going on. So what do you guys think are the upsides and downsides of testing the front end, testing the UI versus, let's say, some server logic or that type of thing? Why don't we start with upsides? Nakeeb said less load on server.
It makes sure that it works everywhere.
Yeah, make sure it works everywhere. So if we want to have our app working on different platforms, then you do need to test it out on different platforms. The UI is what's seen. So there are people that are actually, the UI is kind of that final stage that is actually going out to users. They don't know about your Python Flask code. So that's important because that's what they actually see. And you want to make sure that that is up to a high quality. And less load on server, I think when you're saying that, Nakeeb, the UI is going to handle a lot of things that the server doesn't. And if that's the case, then you would want it to be tested as well, so that all of the kind of risk and like all of the stuff is not put on the server itself. Yeah, there are browser add-ons to help you, like for, I'm guessing, Elvis, you're saying for different device types and screen sizes. There are a lot of useful libraries like Bootstrap, which can allow you to make your site mobile friendly. And it's something we call responsive design in order to make it a lot easier to see things regardless of your screen size. And there is actually a feature that allows you to change your screen. So if you open up your console, then one, you can like decide what the screen size is, but you can also see how does this look on an iPhone X, or let's see, like a Galaxy S5, and you could test it out on your browser itself. So yeah, I think upsides, the UI is important. It's user facing. So we want to make sure that it's stable. We want to make sure that like there's important pages that aren't just going to break randomly because you added some wrong code in. And you want to have that confidence that making maybe an upstream change, like in a parent React component, isn't going to screw up the children below it, something like that. And then there are downsides too, though. I didn't ask you this, but every time that you do make like a small change to the UI, that means that you're going to have to change your test to reflect that change. And you make changes a lot more often on the UI. So let's say changing the color, rounding the borders, just these like small little things we change to the design. And if our test doesn't account for that change, then we could be breaking our tests. So it's a little bit of pain to go back and forth. If you compare that to the server side, you're probably not going to change the logic too much to like get a password or like save something to a database, as much as kind of the design and the styling, which requires smaller, faster changes. And then also testing the UI is not always as intuitive as basic program logic. So you need to think about, how can I open up different devices? How can I simulate clicking on things or making sure something's on the screen? And we're going to see that. So this brings me now to Jest, which is the framework of choice in our class for testing out UI stuff, specifically in React and JavaScript. Jest already comes installed like in our React Starter repository. And this is a testing framework. So it can test React, but it can just generally test JavaScript. So think of it as the unit test, which we were using in Python, but for JavaScript now. And this comes installed, which is nice, which is kind of part of the reason why we included a React Starter, which has a lot of things inbuilt. And I'm going to show you how that looks now in this demo. So let me open this up. You don't have to follow along. If you want, you can open your Cloud9, and there is a test already existing. You might have seen called app.test.js in your repository already. All right, so ask me any questions as we're going through it. Okay, so we did unit testing with Python last class, but now let's see how we can do it in our JavaScript, specifically testing out our React components to see if things are changing as we would want them to. I'm starting out in the function component that I had created in the lecture 12 demo. So basically the one with these chat messages, connecting to a database where you can enter your username, join, and then it'll show up here on the list. I've added in one more thing, which is an is logged in state variable. This can allow me to keep track of whether to show this username here, join button, if you are not logged in, and hide it if you are logged in. So if you go down to the bottom here, I basically said if not logged in, then I am going to show this whole div with the enter username, the input, and the join button. I could actually change it here to the syntax we're more used to, where I have the question mark. Now, if that's satisfied, then we return this HTML. Otherwise, we're just going to return null, meaning we're not going to show anything here. So that's what this looks like. Now let's actually see what a test would look like for some functionality here. If you look in your source folder in React Starter, it should have already come with something called app.test.js. So React Starter out of the box comes with this testing framework called Jest. And this is already installed for you and configured for you. And here's an example of how you can do a test. So this is a test for that original view that we would see where it would show a spinning React logo and like a link to React. If we see what this test is doing here, we start with the word test. The first argument here is basically what we want to be testing. So just a descriptive message here, we would want to render the learn React link. And then the second argument is a function, and everything inside the body of that function is the actual test that we're running. And Jest, as well as the React testing library, which kind of work together, they provide us useful methods that we can use to then basically pretend that we are opening up a component and clicking around and changing things with it. So if we see here, we are rendering the main app component using this render method from the React testing library. And after that, we are using something called screen.getByText. This is screen, again, is another sort of helper from React testing library. And it allows you to look on the screen that you're on, see all the text here, and then just type in like the text I would want in order to find that element. So if you think about document.getElementById, that would be looking through the DOM and seeing where is this ID that I want that you define in your code. GetByText is not really looking at the DOM, or at least like the internal IDs and stuff. It's looking at the actual text that's displayed on the screen. So if I did screen.getByText and then chat messages, then it would return us the element that chat messages is inside of. So that header or whatever. And then the final thing here is we have this expect statement, which is similar to the assert statement that we were making in unit tests for Python. And this is saying, this is the actual test that we're running, the actual kind of confirmation, which is saying, I expect this link element here to be in the document. So again, another helper function. The testing library is going to find this link element on the page and then make sure that it's actually in this DOM. So I guess it's going to look through the DOM and make sure that it sees link element there. This is an old test though, because we don't have the spinning React logo anymore. Let me make a new one now. And this will be to test that basically if I type in a new user here, maybe num15, and then I press join, then I want to make sure that this login or the username input and the button have gone away. So that's one small flow, one small functionality that we want to test right now. You could be testing other things like you could be testing, was I able to successfully type things in before I press send? Maybe if you have some logic that you can't just press send if the input is empty, that could be another example of a test you want to run. I'm going to show you though that the username here disappears. So let's set it here to join button disappears. We're going to take this out. You always start with render. That's just kind of rendering the component that you want, the root component. Render returns something called a result, which you can then use to do other things, such as it can find you like it can basically give you the DOM node that an app is a part of that you can then look through if you want to like see some specific elements, things like that, as well as other helpers, but we don't need it right now. What I do want to do is basically grab this join element so that I can use an expect statement about it. So that's a good question, Josie. Render basically is saying within my test itself, I am going to create this app component. So just imagine that the test has its own little browser and we're choosing to render this component on that browser that we can then test to see if there's things on that component that we expect. So the way that we were doing this in the initial example was with screen get by text. So I'm going to say join button element, and I'm going to use screen.get by text, and then put in the text that this button is a part of. So I could just put in join, and the library will automatically find this button for me. Now we want to actually simulate a user event. So I want to pretend like I clicked the button join so that I can then see that it disappeared. So compared to manual testing, now we're writing this inside of our code here. And you can use a helper called fire event to basically do fire event.click. And then you're going to want to input or like provide the argument, which is the element itself. So I could say click join button element, which I saved right here. So now the testing library is going to click it for us. And then the final thing that I want to do is make sure that the join button has disappeared from the page. But actually, one thing that I can do before that is let's make sure that the element is on the page to start with. So you would use an expect statement whenever you want to do something like that. And I want to see expect join button element, and then you can do that dot whatever your test case is. So we were talking about like assert equal, assert not equal in Python. In the React terms, we might do to be in the document would be that it's showing up on the page. This is nothing that I just like automatically memorized. This is stuff by just like looking through the documentation and examples, you can see good things that you can do. All right. Let's first run this test and see what happens. The way you can do that is inside of your React starter, you can say npm test. And that is going to find all of the jest tests that are written. So anything with the .test.js in your directory, and it's going to be running them. So when I ran that, I'm basically saying there's a pass. So this worked out as expected. So npm test is going to keep rerunning the test whenever you change anything in the file. So you can slowly kind of test out different things and save, and it'll automatically rerun here. Now, the last thing we want to do, we know that this is successfully in the document, this join button. We have simulated a click. Now let's check if the join button disappeared. So I'm going to say expect join button element dot to be in the document, and I'm going to save. All right, so we see that there is a failed test. This didn't successfully disappear. Looks like join button element is not defined. That was just a misspelling here. Let's try it again. And it still fails. So right now it's saying that the element could not be found in the document. Well, that's because the button did disappear. And this line of code here is saying the join button is in the document. The actual test I want to see is basically that this is not in the document, and that's testing that it successfully disappeared. So if I added this dot not dot to be in the document, I'm saving, and now this passes. Okay, that's it with the demo actually. I'm gonna require you to write just a few tests with the front end for like what you define are the more high priority flows. So that could be, is logging in working correctly? Is when I click on a square, is it adding like an X or an O inside of that same square? Very simple things that you can kind of create automation for here. It is cute, Peter. Yeah. So they have a lot of useful methods here that kind of make it very intuitive when I type this in. So expect element to be in the document, that pretty much just looks like English. It's also a little painful because these are all random methods that are created, like not random, but these are all methods that Jest provides, and you need to actually dive into the documentation in order to understand and use all these APIs. All right, any questions with what you're seeing here? Okay. All right, let's keep moving then. Okay. All right, so yeah, the downsides we were talking about with front end testing, they are very real, just like the pain of having to constantly update them as your UI changes, that kind of thing. So you will see that a lot of companies focus more on like server side testing for and like writing tests for that, and then just manually testing the UI. So clicking around or hiring a QA team to click around for you, that type of thing. At least on my team though, as a product is becoming more mature, you will see like a smaller handful of automated UI tests. And this is kind of what I was showing you with Jest. So maybe we will say like, these are the high priority flows that I want to make sure work. And that's why I'm going to automate it with testing. So I can make sure that if I introduce a new code change, I can test it and make sure that my code change is not breaking any of those high priority flows. So that's the kind of balance that we meet between the upsides and the downsides. Okay, we're actually going to move now to a different topic, which is linting. So linting is a piece of software that will look through your code and then output any errors that it's seeing. So these sorts of errors could be your syntax. This could be maybe it's not following the best conventions with the language that they've deemed you should be doing. Maybe the structure is not in the best way. Different types of rules. And the linter is basically going to say, based on what I've seen and based on the rules that I've set, I'm going to give you some score about how the quality of your code is and tell you what you should be fixing. And most linters can actually automatically fix some issues for you. Keyword is here is on some. It's not like you can just run this program and it's going to automatically make your code beautiful. But there are like some easier cases that the linter can automatically take care of. In most cases, you're going to be the one who has to actually look through based on what the linter told you and fix those problems. So what does this look like? For JavaScript, we use something called ESLint, and you're basically going to run a command in your terminal like ESLint and then the file name. And then it's going to spit out a bunch of these rules here. So it's basically saying like in my function, whatever it was, looks like it's github button. Here are all the issues that I found on these lines. Some of these are errors, they're more serious. Some of these are warnings. And it's going to give you like these rule codes, which you can then look up and see how should I actually fix it. And then it can also tell you some of these are actually potentially fixable, and you can add -- fix in order to do that. So in milestone 3, you are going to have to lint all of your JavaScript files and take away all the errors. This is going to hopefully help you if you feel like your code's messy, or maybe you don't know the right way to be writing JavaScript or Python. This is a good guidance for figuring out those conventions. So I'm going to give you 10 minutes now, and I want each of you to basically open up your Cloud9, find one file from milestone 1, so your app.js or board.js, and then run this command. So npx cslint, and then your file. Try that out, see the kinds of errors that are coming, try Googling them, and see if you can fix them. So 10 minutes, we'll be back at 1:22. And let me know any questions in the chat as you try it out. Oops. Yeah, you're going to see a lot of errors show up. You don't have to run anything before running npx. So just this command. Your actual app shouldn't be running. John, looks like you're getting some warnings with the equal sign. Yeah, a lot of these should be pretty straightforward and simple changes. The equals is huge though, because that could actually lead to bugs. If you do 2 equal sign, then false is actually equal to the number 0. If you do 3 equal signs, then there's no way that would work. So with 2 equal signs, JavaScript kind of coerces types to fit each other, and the equality is a lot less strict. Peter, yeah, make sure you're in source. Although you said you're in the right directory, so I don't know. Oh, so the file name should be like the file path. So if app.js is in the same directory that you're calling the command in, then you can do that. But if it's inside of like src, then Can somebody actually try something for me? I'm wondering if there are no React errors coming up. So could you try installing this? I'm going to put it in the chat. I'm wondering if ESLint is not checking your React properly. So try installing this and running the command again. Zach, you might get this issue about React hooks. Like it's going to complain that your use effect is not putting all the dependencies at once. So the errors in ESLint are not always going to be right. This is assuming that all of the errors this is assuming that all of the code or like variables you refer to in use effect is going to also be a dependency. We can't always make that assumption though. Like if it's an empty array, we don't want to listen to any of the variables changing. So that's actually an ESLint rule that I tend to ignore. Just a few warnings is probably normal. John, the error in your life. Oh, file. Let me show you here. So if you see the list of available rules, there are checks and then there are wrenches. The wrenches mean that ESLint will auto fix it for you. And the checks are just like rules that it by default has. As you can see, the wrenches aren't there for a ton of rules. So most likely the rule that you're talking about just doesn't have an auto fix for it. And okay, looks like that extra installation didn't change anything. Good to know. And John, the array literal notation, that I think that's a separate rule. The one I was talking about was exhaustive dependencies. Huh, that's weird, Joseph. I think I've seen that too. I just kind of ignore when I see those vulnerabilities. If everything works, that's all that matters. Oh wow, Philip, you got a long rule there. So it's basically saying to, okay. It's saying that you don't want to, you're going to lose the value of a temporary variable after each render. Again, that might be a suggestion, but if it's intentional, then you know your code and that's okay then. That's good, Ronak. Defined but never used. That's a good place to be. Yeah, let me put the link of the rules here. Okay, I'll give one more minute and then we'll keep going. If you're getting no errors, that's probably good though, because if your code was working, you probably shouldn't have had real errors. You might have been seeing like that little I next to your line numbers while you're coding. And those are actually ESLint errors that are showing up for you. So you might have used that while debugging, that little X or that I that would show up next to your lines of code. And it's the same thing that's going on there. Okay, so come back to Zoom. We're going to keep moving. One thing I want to note here is that linting is very much for like, it looks at specific lines of your code and it's making sure that certain conventions are right. So are you using the right formatting or styling, different things like that. Linting is not going to be able to tell you though, like, is my approach to how I'm coding this correct? So maybe if you're calling like 3 different functions when you only need to call one function, then linting is not going to be like, that's a better way to go about it, because it's only looking at these sort of simpler conventional rules, not the higher level structure of your code, the approach that you're taking, that sort of stuff. By the way, Philip, you're messaging me if you meant to send it to the chat. Yeah, so IDEs, they usually connect to your linter. So our Cloud9 is already coming connected to ESLint, which is why we can see those errors and warnings directly on the file instead of needing to run this. And this is something that you're going to see used like at Facebook. We always have ESLint connected and it's kind of always running and showing us things that we can improve. And hopefully, once you kind of see these rules more and more often, you're going to have a good idea of the code that you should be writing or how it should look without even needing to rely on lint. All right, and the next thing I want to talk about is linting in Python. So every programming language has a linter or multiple linters that you can use. In our project for project 2, milestone 3, we're going to be using PyLint on the Python side. So again, I'm going to make sure that you lint your Python files and have a certain score. So if you see here as an example, you basically run PyLint, then the name, and then it'll give you all these errors or issues as well as a rating out of 10 at the end. So why don't you take 10 minutes now and try this out for yourself. You should have PyLint already installed. Try pylinting like your app.py. I'm guessing that's the only Python file most of you have right now. And if you want to know about the messages you're getting, you can check this website with all the rules. Same thing, just for Python. Yeah. You may see more errors on the Python side. I did too. Yeah, they have these for all languages. So any major language is going to have a linter that you can use. Elijah, 2.4 out of 10. Honestly, I mean, last class people were in the negatives, so that's also normal. You're honestly doing okay. If you're above 0, I wouldn't worry too much. Ah, there we go. Yeah, -3, Brian. Nice, Ronak. A solid 0. Mike, yeah, I suggest app.py, but like if you have other Python files, try them all out. 0.10 out of 10. That's trippy. Try fixing them. They're gonna go up a lot faster than you think. Oh my gosh, Philip. 9 out of 10. Mike, if it's not working, try reinstalling it. Does it say that it has the command? Yeah, some of these are a pain, especially the white space. It's going to be like you have an indentation when we don't want you to have one. There's also like comments, different things. All right, Mike, you got it working. Again, low numbers are totally fine. They go up really fast when you change the dumbest things like white space and commas. But you will need like 9 or 10 out of 10 for project for milestone 3. Yeah, naming is a big thing as well. Make sure that on the Python side, you want snake case. On the JavaScript side, you want camel case. Mike, what's your question? Oh, I'm talking about Pylint. I have to look into the ESLint scores. Screaming snake case. These are annoying conventions, but this is what you're going to see like in the industry. So you're going to be expected to follow these sorts of things. Oh no, Joseph, you went down? Ah, Philip, yeah. Probably wants like socket.io type of thing. I mean, that's kind of usually the example code we're looking at doesn't even have it in uppercase. So these are kind of smaller things. Natham, we're not going to use session from Flask. That is something you can look into on your own if you want to consider it for project 3. Isn't Pascal case with the first one also capitalized? I think that's what we do for React component naming. And then JavaScript naming should be camel case. All right, 2 more minutes, then we'll come back. What's up, Rona? What makes a good doc string? I honestly don't know. I don't use doc strings much, but you should basically be giving context about why there's a separate Python file. What is the purpose of that file? What sort of logic does that whole file encapsulate? The goal for these sorts of documentation strings are that when you're writing your own code just for yourself, you obviously know what it's for. But when you work with 100 other engineers, then they're not going to know necessarily why you have a separate file or a separate function. So you're giving them a context. Yeah, import modules. I think if you're importing the DB or like the models, then you can ignore that. 6 out of 10, nice. Philip, yeah, that's a good example for the function string. Yeah, mainly for others. That's why documentation is key. Plus, like maybe you're gonna leave the company, then they might just be stuck and not know why this file exists. I don't know if there's an auto fix for Pylint. I haven't seen one. You could kind of look into other linters with Python and try to find one though. True, Gerard, yeah. Once you're out, you're out. That's what I'll do. I'll let Facebook crash and burn right before I go. Yeah, exactly. Or introduce like some very small bug that you don't test and you know that it's going to come out later on and screw things up. Honestly, bringing down a company like Facebook, you got to be a mastermind. And yes, you have to be willing to go to prison. Congress. Okay, let's keep going. So yeah, with this linting, we're basically working with a bunch of set rules. So Pylint and ESLint have defined these rules for us based on some standards that they know about. And then they're requiring, or they're kind of taking action based on those rules. But you can totally customize this. Rules are very subjective. So you can disable some rules that you don't like. You can enable different rules. So ESLint might actually have a lot more rules. You see best practices here. Maybe it's not actually including those because they're not enabled right now. And you want to get the full linting experience and see like what are some things that I actually am missing. I want to be the most strict I can about things I can improve. Then you can also enable more. And there's a bunch of different kind of rule sets. So right now we're doing the recommended one, but there's other ones too. And another thing that's cool is you can kind of customize and create your own rules. So I've done this actually at Facebook too, like on my team. Sometimes there are like team specific rules that you want to enforce, or Facebook specific rules you want to enforce, or whatever your company is. And you can write your own rules to do that. One thing like I've done is maybe our team specifically, we're not supposed to be using this certain library anymore. You could write a rule where anytime somebody tries to use that library, it'll give them an error and be like, you're not supposed to use this. So simple things like that. Nice, Droid, 7.6. Okay, so that's linting. Unit tests, mocking, and linting, they kind of are the trinity for avoiding bugs. And you're going to see this most often enforced at places. This is going to help you avoid like a huge portion of your bugs, like 75%. I don't know if that number is true, but there's another kind of smaller portion, which will be from the UI. And these are going to be relating, like you can address those in different ways, maybe more manual testing, a QA team, maybe some basic front-end tests like we were showing you, different ways of doing that. Some bugs just come from like scalability. So as software grows, you don't necessarily have the foresight to know if it'll be able to take on like much larger, I don't know, if the server can take on having more users, if your function can take on having a lot more if statements and different code added inside of it. Code changes over time, and you need a lot of planning and forethought to think about how can I make this most robust for changes in the future. And that'll help you prevent those sorts of long-term bugs that you don't really expect and they come in much further down the road. But we're not talking about that right now. There's another chunk of bugs that actually come from typing. So Python and JavaScript both have very loose typing. They don't have any sort of like static type checking like you would see with Java. And you don't need to actually define like when I create this variable, I want it to be an int or I want it to be a list or whatever. This can be a big issue because JavaScript is super forgiving with types. It'll like convert types into each other if it can. And that's what really can lead to bugs. And you don't necessarily know like what types you're dealing with because you don't have much insight into them. This is where like typing languages, I guess, come into play. You have them for Python. I'm going to talk about JavaScript though, because that's what you see most often. There's something called TypeScript. You might have also heard of flow or closure. So at Facebook, we use flow. At Google, I think they use closure. And these are all sort of supersets of JavaScript that allow you to write all your normal JavaScript, but include type annotations inside of it. And they enforce that. So this is what you're going to see a lot of companies using instead of plain old JavaScript without types. And this allows you to just have better code and avoid bugs. I'm not going to actually force you to use TypeScript for project 2, just because I don't want to introduce too many things at once now. We've already covered a lot. This is something though that I highly recommend you look into for project 3. And it's not that big of a learning curve, but it will save a lot of time from that you would be spending dealing with bugs. So TypeScript, basically you can install it using npm in the same way that we've been installing stuff. And basically what you're going to do is add type annotations to all your variables and functions and whatever. And this is going to help you understand like and enforce that you're using types consistently across your code. Just to show you an example here of how that looks. On the left, you see TypeScript or JavaScript, plain JavaScript. On the right, you see TypeScript. So I have this function here called getPassword. It's taking in an argument, clear text password. And basically, I'm using this as a Boolean here because I'm saying if clear text password, so like if true or false type of thing, then I return this. Otherwise, I return like the stars password type of thing. And if I tried to call this function with a string instead of a Boolean, this would still work because there's no type enforcement here. If I said if clear text password, then it's just going to be like this string is a truthy value. Like I can convert this to true. That means I'm going to say that I return password here. That's not necessarily what you would expect though, because the developer of this function probably meant they want to use it as a Boolean. So that's where TypeScript comes into play. You can basically instead be like, here's my function. This is the arguments type, the Boolean. This function is going to return a string. So you use these colons to basically say the types or annotate those types on. And then you have the same code inside. And if I tried to call getPassword with a string, this would throw an error because I can't pass in a string into a Boolean argument. And yeah, this is exactly like C++, something that you're used to in a strongly typed language. And you're probably going to notice that you run into bugs less in a strongly typed language, even if it's more of a pain to write the code. The other benefit though with having these types is that imagine like when we're taking in socket data on JavaScript side, we basically do socket.on, the name of the event, and then we have that argument called data. So that argument, we don't necessarily know always what is inside of data. We know it's some object, but we have to actually log it when we run the code in order to see what's coming back. If you have a type, or if you've typed that argument, then you know that this is exactly what comes out of data. It should have these fields like first name, last name, and then strings, and like those are strings. And then later on, if I'm ever referencing data in my code, I could just hover over data and it would tell me this is an object with these keys of those types. Similarly, like if I hover over a function, it could tell me this is a function that takes in an argument of this type and it's going to return back something of this type. And that can be just useful to work with APIs, work with different functions that you're making or external functions that other people have made, and automatically know what kind of things that it expects and returns. So it's super useful. I highly recommend you take it on in project 3. And that's actually it for today. I guess before that, does anybody have questions about TypeScript? It is a separate language, basically. So you don't have to treat it like they call it a superset of JavaScript because it's everything JavaScript is and more, meaning you just have to have these types. So EC, like this ECMA script, that is JavaScript. That's regular JavaScript. That is just kind of the standard that we talk about with JavaScript. So you'll see ES6 is the latest standard that we use because the JavaScript language itself has versions and it's changing the latest standard. TypeScript, though, is kind of a superset of ECMA script. It is taking ECMA script and adding type annotations to it like this. And yeah, you can use TypeScript with React just as you were doing other things. It'll work perfectly fine. Cool. All right, highly recommend you play around with it, look around with it. If you want, you could use it in project 2, but if you don't want to introduce a new tool, then project 3 is the way to go. Okay, guys, so that's it for the week. We are going to be talking about more non-technical stuff next week, actually. Homework 13, which was from last class, the testing one, it's optional and it's still open, but I encourage you to do it at some point just so that you're comfortable with testing for milestone 3. And otherwise, milestone 2 is due this Saturday. Remember, you have 3 late days though. And if you're stuck, then Slack, office hours, reaching out to me, will get you where you have to go. So good luck on that, guys. You can all do it. This is going to be a lot easier for you, hopefully, because it's building on milestone 1 and that pain that you've already built up. If you ran TypeScript syntax in a JavaScript file, yeah, I think you have to end the file names with .tsx. I can't actually remember though. No deadline extensions, Mike, just because we do need to finish this by spring break. The goal of this is that we have all the time after spring break to work on project 3 because that's like the big project. You can do it though, and you do have late days, remember that. All right. Okay, guys, and the cheat sheet is up here. You can look through it and see like anything you need to catch up on with milestone 1. Project 3 is going to be open-ended. I can talk about it more in the coming weeks, but you basically get to choose what you want to do as long as you have some basics like a database and users and things like that. And it's a group project, groups of like 3 or 4, randomly selected because that's how we work with people in the industry. We don't get to choose them. You will have an industry mentor actually that I'm going to be assigning each group to somebody that you can talk to and get ideas from, things like that. And it'll be about a month. So it'll be starting end of March and then ending by the end of the semester, so end of April. A real worker from the industry. So people that I need to find still, but either at Facebook or other companies, grad school, different things. So that should be cool. Yeah, I'll bring Zuck in. Hopefully he'll come through. Elon, yeah. Torvalds. I'll try my best. Try my best. Oh man, I'm not playing with the dead, guys.